Saxon Algebra 2, Lesson 33. We've got 2 topics today, you guys, but this is a fun lesson, super algebra-y and fairly direct and to the point. There are 3 major rules of algebra. We use them all the time. I know you know them. Hannah Cranny is their queen and high priestess, so it's really it just boils down to what's fair. The first 2 relate to equations. All right, and we use these all the time, and I'm going to put them in shorthand, but I want you to copy them down. Number 1 is that you can add or subtract any number to both sides of the equation. As long as you're doing the same number to both sides and the same sign, right? Then you're not changing the equation. You're not changing the value of it. You're just changing the form of it. So that's perfectly legitimate. And we do it all the time. We swim fish, right? The second one is that we can multiply or divide any number except 0. To both sides. Of an equation. We do this all the time. We just have to be careful here. We can't divide by 0. That's just really bad and the kingdom falls down, right? So that's the problem with dividing by 0. These are the 2 rules. Like I said, we use them all the time. We can add and subtract. We can divide both sides. You've been doing it for so long, it probably seems like ridiculous to even mention it. The third rule of algebra relates to expressions. An expression has no equal sign, right? It's where we're told to simplify, right? Equations, we're told to solve. Expressions, we're told to simplify. Okay, that's kind of key in helping to figure out what it is you're doing in a problem, is to look at what that instruction says. All right, with expressions, we can't do this because there aren't 2 sides to keep in balance. So we have to use a different strategy for changing it, and this is fancily called the Denominator Numerator rule. And what that means is that you can multiply or divide any number except 0 for the same reasons up here to top and bottom. Of a fraction. I'm going to bump up a bit. Okay, and we do this all the time too, right? Like when you're adding fractions, if you want to find the least common multiple and then multiply to change the denominators, that's what we're doing. We're using this denominator, numerator, same quantity rule, which is a fancier spin I just put on that. So these are the 3 rules of algebra. These 2 relate to equations. This one relates to expressions. This is the one we're going to use in the second part of our fabulous lesson 33, because now we are ready to talk about complex fractions. I hear excited murmurs of delight going through the crowd as you watch this. I don't even know if you guys watch this together. I think you do. But I'm just imagining just ripples of excitement as your math mammals purr in contentment, knowing that one of their favorites is coming up. Okay, let's take a look at how these work again. I can't remember if we've reviewed these yet this year or not, but we're going to dive in. Remember, a complex fraction has more than one division bar. That's what makes it a complex fraction. That's messy. Okay. Whew. 1, 2, 3, 4 division bars. I exaggerate the biggest one because I want to make sure I can tell which is the biggest one, because I know that I want to go to the bottom of the biggest fraction and turn this into a 1. That is my goal. If I can turn this in, yes, a 1, then it goes away, and now I'm just working on one level, right? I don't need this double-decker fraction business. And our goal in simplifying these is to get it down to just one division bar. So we go to the basement down here, trudging down, and we figure out what's it going to take to turn this sucker into a 1. Well, the best tool at our disposal is the reciprocal, because the reciprocal will always multiply with its partner and turn into a 1. Just to remind you, it would be AY over AY, which is equal to 1, which poof, disappears into thin air, and our denominator is not a problem anymore. However, we've got that third rule of algebra we just talked about, that denominator, numerator, same quantity rule. So if we're going to do this down here, if we're going to multiply it by YA, then guess what we have to do up here? Also multiply by YA. Okay, so now we're in balance. That's good. This, though, we've destroyed, so we're good with that. Now we just have to fix this up here. Now, whenever we're multiplying one thing by two things, it really helps if we do that, doesn't it? And we have options. We could distribute this, right, and then try to add the fractions in the end. But, excuse me, I see how easy it's going to be to fix these two and smush them together. And I'd kind of like to make this one fraction before I multiply it by this. I'd like to make things smaller before I make them bigger, right? So I'm going to add these two, and then I'll multiply. So in order to add these, they have to have matching denominators. This just needs to be multiplied by x over x, right? Then they'll be matchy. So I'm going to bring this down here. This is going to become x squared plus 4. All of that is now smushed together over a denominator of xy. I'm gonna write it like a civilized person and put it in order. This has to be multiplied by y over a. Make sense? I just brought this as that, and then this is this. Okay, beautiful. Now, before we multiply, we look to see if there's anything canceling. Well, and I pay attention to that plus sign, because I can't cancel anything in here unless I factor it out first. But this is just an A, and there's no way A anywhere in sight, so forget about that. These guys are ripe for canceling, aren't they? And I'm only multiplying, no addition down there, so I'm good. So my final answer, multiply across the top, x squared plus 4 over x. Not the body spray, the chopping implement, which can be spelled either. The chopping implement can be either of those, but the body wash, I'm pretty sure, is that, isn't it? I don't consider myself an expert, but I'm pretty sure. So this would have to be the chopping implement. All right, I digress. Wasn't that fun? I enjoy those so thoroughly, you guys. Let's try the other one, and then we're done with this lesson. We'll have to find something else interesting to do. Oh, I know. Watch lesson 34. 33.2. Ready? Oh my gosh, it's a mess. I'm trying to go slower. I know I go too fast. It's a problem. All right. Lots of division bars. Lots of letters floating around. Our strategy is the same. Go down to the basement and try to turn it into a 1. All right, well, now this is a creepy looking little denominator, but it works exactly the same. As long as it's one fraction, all we need to do is flip it. Right, because both of these, I'm going to show you this just so you believe me. This will turn into x times quantity a plus m. And the bottom, let's just write it in the order we found it. That all turns into 1. It goes away. But before we totally destroy it, we better remember Hannah Cranny and that third major rule of algebra. We have to multiply the top by the same thing we multiplied the bottom by. And I will tell you, I've seen many a student make just the silly mistake of they write the fraction, then they write the reciprocal, and then because you're just used to flipping it, they flip it again back to this form to write it up here. Make sure these two are the same. It's just a silly little mistake people make. All right, so we take a minute and we just pat ourselves on the back for a job well done down here. We're back, while we're upstairs where there's light. I always think of a horror movie, right, where all the bad things happen downstairs. Now we're back up in the light. We're fine. We need to multiply this by this, but again, this is a binomial. So we want to squish that before we multiply by that. Let's make this smaller before we make that bigger. So, before we make it bigger by multiplying, we have to combine these. They need a matching denominator. So, I know many students' brain says, well, can't we just add x to this and add x to that? No. We get least common multiples only by multiplying, and the only way to do this is to do quantity x plus y times y. It's the only way it's going to fly. So, what that means is we're going to have to multiply this side by y over y. Denominator, numerator, same quantity rule. And then this one, we have to multiply by the whole binomial business, like so, right? Now I'm going to multiply and go down here. I'll do this, that's ay, plus, and I'm not going to distribute that. I'm just going to leave it m times the quantity x plus y. Maybe later I'll be motivated to do that, but right now I'm keeping it simple. All of this is over y times the quantity x plus y. Okay, so there's all of that. Now I have to bring this down. A plus m over x, right? That's that. I brought it down. It's the reciprocal. Now we're ready to multiply. Can we factor anything? Well, there's a little x buried in there, but I can see these terms don't have any x's in them. There's no way I'm going to be able to factor an x out of everything. And these guys don't even have the same letter, so they're a hopeless cause. So, no, I can't factor anything. So, I'm now ready to multiply. And what I'm going to do is I'm going to put all of this inside bigger parentheses and this in parentheses because we're multiplying this whole chunk by that whole chunk. And this plus sign tells me that I have to connect all of this and I can't just let it flow into that. I have to show that this whole sum is being multiplied by that sum. Annoying. AY plus m times x plus y quantity, and then that's all a big quantity, times a plus m. And these guys can frolic a little bit better. I can just put this x up here by the y, and then they both are multiplied by the x plus y. All right? So then, I don't like this double parenthesis thing. So what I've decided is I would like to distribute that. So I'm going to write it one more time. AY plus MX plus MY. That's the first quantity. And I like it better because I don't like having parentheses inside of the parentheses. So I distributed that and got this. I'm much happier. This A plus M stays the same. And then this whole denominator stays the same. And that is the final answer. Now, it's fair to say, which was prettier, this original or this? This is a monster, isn't it? Well, you can argue that, but this is considered a basic fraction, and it's no longer a complex fraction because it just has the one division line. And granted, it's a mile long, but still, it's only one division bar. So slow clap for us. Lesson 33 is now accomplished. We're moving on to 34, and I look forward to seeing you then. Goodbye.